Okay, so we had a little accident with the memory card filling up, but right when the memory card filled up, and fortunately we got a beep. So we were just talking about we had this equation, and what was the problem?
Well, the problem is we've got two unknowns in one equation,
Okay.
and we don't know. We can't solve that. We can't solve it for x or for y.
Right.
So we can get a second equation by looking at this line, which is also blank 8.
All right. So can you tell me what this equation's going to be?
So it's 64 equals y squared plus, in parentheses, y plus x squared.
Okay. So we have now two equations. 64 equals 2y quantity squared plus 2y minus x quantity squared, and 64 equals y squared plus y plus x squared. Now we have two equations and two variables. And what were we hoping to show?
We want to show y equals x.
We'd love to be able to show that y equals x here. And so, since we only have one whiteboard, actually, you know what? I said we only have one whiteboard, and I turned around and another whiteboard was there. Oh, this one's got a little mark on it, but that's fine. Can you move this one away?
So right there.
All right, what are our equations?
So you have 64 equals...
You can multiply them out. Let me write them this time.
Okay.
So 64 equals...
4y squared plus 4y minus 4yx.
4y squared.
Yeah, 4y squared plus, 4y squared minus 4yx plus x squared. So that's our first equation.
Where did that equation come from?
So this is the top one. You multiply it to 2y squared.
Yeah.
You do 4y squared.
Uh-huh.
And then 2y minus x squared.
Go ahead and multiply 2y minus x.
So you get 4y squared minus 2yx minus 2yx.
Okay.
Plus the x.
Alright, do you understand that?
Yeah.
Okay. Alright, good. Alright. And what was our second equation?
So second equation is 64 equals y squared plus y squared plus 2xy plus x squared.
Okay.
Well,
And we're hoping to, if we can just show that y equals x here, then we'd be in great shape.
so
Well, couldn't we just, if we flip this equation and subtract the 64s, we could set these two halves equal to each other, and then we could simplify a little.
Okay, yeah, that's a great idea.
so
Since they're both equal to 64, that means they're equal to each other.
so we can say, I'll do this one on the left, we can say 2y squared plus 2xy, or just do yx to keep it consistent, plus x squared equals 8y squared minus 4yx plus x squared.
Okay.
So
we
we can
can
simplify a little
We can
bit.
get rid of the x squared.
The x squareds can subtract out. A bit of the y squared can subtract out. So we have 6y squared. We can move the 4yx to the other side. So we get 6yx equals 6y squared. So yx equals y squared, and
I'm going to see if you can switch to a...
yeah.
yx equals y squared, okay.
And we can divide.
So x equals y.
Well, how do we know we can divide that y out?
Because they're side lengths in a square. So
What's the situation where we could not divide the y out?
if the small square was 0,
Okay.
but that would mean the bigger square is also 0. So
Alright.
that's not gonna happen.
Okay, so we get x equals y, and when we set x equals y
So
into, what do we get?
That means that the center of the semicircle is exactly, it's in the center. It's at the midpoint of this square side length.
Okay.
So we can set x equal to y in either of these equations, and we get the equation for the area.
All right. Okay. So here's, all right, but you notice that if x equals y, this big square, the center of the square is right in the middle.
Yeah.
So what does that imply?
Well, then we can set up, so each of these halves are 8.
Yeah, the geometry though. What geometry does that mean if the center of the circle is at the center of this square? Forget the equations.
Well, it means these two triangles are the same.
It certainly means that. It
Oh,
means
okay.
something else though. If the center of the circle is at the center of the large square.
Mm-hmm.
What does it mean about the picture?
So, well, each of these halves are going to be 8.
That's right. But we knew that already.
Yeah.
The center. There's something else though. Draw it. Erase and draw it. Where the center of the circle is equal to at the center of the big square. And here we said that things were in the ratio of 2 to 1.
Oh, that means that this is actually touching both sides. And then your small square is kind of off over here.
Okay. Why did it mean that?
Well, because we saw that this length was
Yeah.
8.
Uh-huh.
So going from the center to here, so this length has to be 8. And that's only true if this corner is on the edge of the circle because it's a radius.
Okay. So by total accident, actually, we landed back on the first case you wanted to try.
But now we know that we know the area is 64 in both cases, and we know the small square actually does exist here.
Interesting. Okay. So does this solve the problem in general?
Not yet, but it gives a strong hint as to the answer is 64 for all cases.
Okay. Yeah, off camera, I'll show you a quick proof. That actually, I'll show you an algebraic proof because it's very similar to what you guys did, but I'll just do it in general.
Right.
I'll do it off camera. But your work here was really great, guys. Good job.